Hey everyone, Dale here with Renewable Innovations. A few weeks back, I did a video talking about SPAN and XFRA, exploring the idea of turning homes into part of a distributed AI compute network. Basically, instead of building one massive data center, the idea is to place smaller AI compute nodes at homes that already have electrical infrastructure, battery storage, solar, or smart energy equipment. And now Sunrun is testing something similar. They recently announced a distributed AI data center pilot where compute nodes would be installed in customers' homes. And those homeowners would be compensated for hosting the equipment. The idea is that Sunrun could use homes with solar and battery systems to support AI compute workloads, then sell that compute capacity to enterprise customers. Now, this video isn't really about Sunrun's announcement specifically because honestly, there are not a lot of technical details yet about what they're actually installing. They've said enough to make the concept interesting, but not enough for us to price out their exact equipment. So instead, I want to get a little nerdier and look at the version we do have more information on, and that's the XFRA home AI node concept tied to SPAN, because they're shown enough equipment that we can start asking the real question. How much would one of these home AI data nodes actually cost? So with that said, let's dive into this. Now, based on what XFRA has shown publicly, this is not some little gaming PC sitting in your garage. This is an enterprise-grade equipment. We don't know every single configuration detail, and the pricing will obviously vary based on bulk purchasing, partner agreements, and the final deployment specs. But we know enough to get a general idea of what this could potentially cost. And I think that matters because it plays a direct role into whether these programs actually work for homeowners. If a company is putting up hundreds of thousands of dollars of equipment at your house, paying you to host it, and they're handling the installation, the power, the cooling, the internet, maintenance, there's a lot to go on here. They need to have a pretty strong business case on the back end. Now, from what XFRA has shown on their website, the system includes 16 NVIDIA RTX Pro 6000 Blackwell Server Edition GPUs, 4 AMD EPYC CPUs, 3 terabytes of RAM, 2 Dell PowerEdge XE7745 servers, connecting all of that together, and a 24-port gigabit switch. That is absolutely wild for something being talked about in a residential setting, let me tell you. To put this into perspective, a pretty serious consumer gaming PC might have one high-end graphics card, maybe an RTX 4080 Ti or a 5090, depending on the build. This concept is showing 16 enterprise Blackwell GPUs, multiple server CPUs, terabytes of memory, liquid cooling, and enterprise server hardware. This is not a toy. Now, before we start adding up prices, I want to thank today's sponsor, AP Systems. If you're interested in producing some of your own power, but you're not ready to install a full rooftop solar system, the AP Systems EZ1 microinverter is a really great product. It's designed as a small, plug-in solar system for backyard setups, giving homeowners, renters, and DIY-minded people a simple way to offset part of their electricity usage. I'll have my affiliate link and discount code down in the description below if you're curious to know how much one of these might save you. Now, let's get back into this home AI node because the hardware cost starts getting ridiculous pretty quickly. The RTX Pro 6000 Blackwell Server Edition is not a normal consumer graphics card by any means. NVIDIA positions it as an enterprise data center GPU for AI, graphics, simulation, and interface workloads. The retail price I've seen floating around for these cards is close to $12,000 each. And if you need 16 of them, that puts the GPU cost alone at $192,000. Now, obviously, XFRA or any company deploying these at scale is not going to be buying them the way some random person orders a graphics card online. There will likely be enterprise agreements, partner pricing, or some other negotiated cost structure. But even if you discount that number, the GPU stack is still an enormous part of the system cost. Now, they're showing 4 AMD EPYC CPUs. We don't know the exact generation or the core count, but if they're using enterprise-grade EPYC processors, the pricing can vary a lot depending on the model. You could be looking at something like $5,500 on the lower end, all the way up to $14,000 or more per CPU. So for 4 processors, maybe you're looking at $22,000 on the low side and more likely $56,000 on the high side. But then we get to the memory, and this is where things get even crazier. They're showing 3 terabytes of RAM. If the system is using enterprise DDR5 memory, like I assume, and if that memory is spread across 12 sticks, like the image appears to show, they're talking about 256 gigabits per stick of RAM. That is not normal desktop memory. That is high capacity enterprise memory, and it is extremely expensive. Depending on the exact type, speed, and configuration, I would not be surprised if the RAM alone is somewhere around $90,000 or more. Now, the Dell PowerEdge XE7745 platform is also not cheap. Dell positions the XE7745 as an AI server platform for interface and model fine-tuning, and Dell has highlighted configurations using NVIDIA RTX Pro 6000 Blackwell server GPUs. Depending on configuration, these systems can get very expensive very quickly. A base system with pretty much nothing in it might start somewhere around $48,000, but once you start loading it with the GPUs, the CPUs, memory, cooling, storage, networking, support contracts, and software, you can easily get into the $300,000 range per server. And XFRA's concept on their website shows freaking 2 of them. The funny part is that they list a 24-port gigabit switch like it's a major part of the build. Like, oh yeah, we got this in there. In the context of this system, the switch is almost a rounding error. A solid server-grade switch might be around $1,000, maybe more depending on what they're actually using. But when you're talking about hundreds of thousands of dollars of GPUs and server equipment, the switch is not what's making or breaking this project. So I don't even know why they're listing it. So all in, before installation, I could easily see the hardware package being somewhere in the $500,000 to $700,000 range. And once you include the enclosure that is being built in, the cooling system that's integrated into that, the site work, the electrical upgrades, the labor, the permitting, commissioning, I mean, there's a lot going on. And of course you got ongoing service. I don't think it's crazy to say one of these deployments could approach $1 million. $1 million. Now, that sounds insane in a residential setting, especially if it's getting installed in a home that maybe is worth $250,000. It's like, oh yeah, I got a server over here for $1 million, you know, and they're paying me to have it. Like, you know, but we have to compare it to what it costs to build traditional data center capacity, right? We need to look at that $1 million cost and correlate it to something. An AI data center are usually discussed in terms of power capacity, and depending on the build, location, power availability, cooling design, and infrastructure requirements, data center deployment could cost tens of millions of dollars per megawatt. Some estimates of AI optimized data centers put the cost around $20 to $35 million per megawatt. So a larger gigawatt scale build out, I mean, they can easily get into the tens of billions of dollars. So if this home AI node consumes around what I'm estimated about 12.5 kilowatts continuously, that's about 1.25% of 1 megawatt. On its own, it's tiny compared to a full-scale data center. But if you scale it up, the math gets interesting. 80 homes at 12.5 kilowatts each gives you about 1 megawatt of distributed compute load. 8,000 homes gets you roughly 100 megawatts. That starts to look a lot more like a real data center, except instead of putting everything in one massive building and taking farmland from people, you're distributing the compute across thousands of homes. That's the pitch here. Now, does that make it better? I have no idea. I don't know. Distributed computing has advantages. It can potentially reduce the time needed to interconnect new load. It can avoid some of the local oppositions that massive data centers continue to face. It can also be used in existing residential electrical infrastructure. It can place compute closer to certain users or workloads. And if the home already has solar and batteries, maybe the energy side can be optimized, like XFRA and SPAN are saying, in a way that makes sense. But it also creates a ton of complexity. Now you have thousands of sites instead of one, thousands of homeowners, thousands of internet connections, thousands of electrical installations, thousands of cooling systems, thousands of places where something can and probably will go wrong. And that's before we talk about noise, heat, reliability, maintenance access, cybersecurity concerns, warranties. What about the home insurance? I mean, what happens when a homeowner sells the house? That's why I'm fascinated by this concept and doing another video. But I'm also not ready to call it the future just yet. The installation side alone is not simple. I could easily see one of these requiring multiple trades being involved. You're going to need an electrical contractor because this is a large continuous electrical load, and it has to be integrated with the home's electrical system safely. You may need an IT or low voltage contractor because this is enterprise compute equipment that needs networking, monitoring, and proper communication setup. And you might need an HVAC support because heat rejection is a huge part of running dense compute hardware. This is not the same as hanging a solar inverter on the wall or some solar panels on the roof. And that's actually a good reminder for anyone watching from the Simi Valley area or nearby communities like Thousand Oaks, Glendale, or Pasadena. If you need a trusted electrical contractor and you need electrical work done at your home or business, Slaze Electric offers a full range of residential and commercial electrical services. Whether it's a main panel upgrade, EV charger installation, home backup, lighting upgrades, troubleshooting, or just getting an old electrical system cleaned up and brought closer to today's standards, having a real electrical contractor that's reliable and trustworthy is very valuable. I've included Slazik Electric's details down in the description below for you to give them a call. Now, the big question is how homeowners would actually be compensated. Sunrun says participating homeowners in its pilots programs are compensated for hosting compute nodes, but the public announcement doesn't give us a detailed payment structure yet, so yeah, it's not very helpful. With the SPAN and XFRA concept, some online reports and discussions have mentioned models where homeowners could receive significant compensation or have energy and internet costs covered. I've seen numbers tossed around like $1,000 a month or $30,000 per year. But until the actual contract terms are public, I would treat all of that as preliminary because the contract is everything in this configuration. And honestly, this is where my solar industry brain kicks in because we've seen what happens when companies rush into homeowners' houses with complicated contracts and big promises. Some of those programs can be great, some can be confusing, and some can be sold in ways that homeowners don't fully understand what they are signing up for. Now, from the company side, right, if I was one of them deploying it, I understand the appeal. The demand for AI compute is exploding, and traditional data centers are expensive, slow to build, and increasingly difficult to permit in some regions. Power availability is becoming one of the biggest constraints besides water. And if companies can create a distributed compute network using residential sites that already have electrical infrastructure, batteries, and possibly solar, that could be a very attractive concept. It's basically the same logic as a virtual power plant, but instead of only dispatching energy from home batteries, you're also placing compute load behind the meter and coordinating it with the home energy system. And that's where this gets really interesting. If the home has solar, it has batteries, and maybe a smart panel, and a controllable compute node, the system could theoretically decide when to run compute workloads, when to store energy, when to reduce loads, and when to participate in the grid services. And that's kind of what SPAN and XFRA are showcasing here. That sounds really futuristic, but it's not that far away from what the industry is already trying to do. The question is whether the economics and logistics actually work at scale. Because again, 80 homes equals roughly 1 megawatt of compute load. And 80 homes also means 80 installations, 80 internet connections, 80 thermal environments, and 80 opportunities for something weird to happen. A centralized data center is expensive, but it's controlled. Distributed compute may be faster to deploy in theory, but operationally, it could be a nightmare if not managed extremely well. So is this the future? I have, again, no freaking idea. But it is absolutely one of the more interesting things happening in the intersection of solar, batteries, AI, and home energy. And even if this exact model does not become mainstream, I think it tells us where the industry is going. Homes are no longer just places that consume electricity. They're becoming energy assets. And now, apparently, they might also host AI infrastructure, and that is just wild. So my final take is this. The concept is fascinating, but homeowners need more details before deciding whether this is something they'd actually want at their house. The hardware appears extremely expensive, the installation is likely complex, and the compensation would need to be strong enough to justify the space, access, noise, heat, and long-term obligations. For companies like Sunrun, SPAN, and XFRA, this could be a creative way to unlock distributed AI compute without waiting years for new data centers and utility interconnections. But whether it becomes a real market or just another flashy pilot program is still an open question. Let me know what you think down in the comments. Would you host an AI compute node at your home if the company covered your energy costs or paid you every month? Or is this one of those ideas that sounds cool until you imagine a $500,000 server cabinet sitting next to your electrical panel? It seems like a pretty big liability. If you found this video helpful, please give it a thumbs up, subscribe to the channel, and stick around because we're going to keep covering this emerging space as more details come out. As always, I'm Dale with Renewable Innovations. Thanks for watching. I really appreciate your support, and I look forward to seeing you in the next one.